ladies and gents. It's me, Mr. Lisham, your science teacher again. I haven't had a look yet at your work from last week about freezing and the change of volume, but I hope it wasn't too difficult. I also just want to kind of put it out there. I did say in the beginning that you must never really stress because of all these tasks, okay? These tasks meant to be fun. Now, I'm totally aware that some of you might be more difficult to do because maybe there will be some things that you won't have at home. Please don't stress. Okay, it really is optional. Okay. Today we're going to do something that actually is very easy and everyone's got that. I've got a little bit of a warmish water here, and yeah, what we're going to do something today is something that you've seen so many times, but I don't know if you've ever really thought about it that well. So I'm going to take some salt. Okay. See, I've got some salt here, and I'm going to put it into the water, and I'm going to stir it. Okay. Obviously we'll work with sugar as well, and you can very easily see that salt is gone. Where is the salt? Okay, I'm sure you've done it many times, probably more with sugar than water. Okay, sugar rather than salt. But my question is, where is the salt? I can't see it. Is it gone? Okay, if I taste the water, it's going to be salty, so it's definitely there. Where is it? Okay, think about it. Where is it? Okay, so let's try and understand exactly what's going on. Okay, so I think some of you already figure out that the word we're looking for is dissolving. Okay, we're dissolving the salt inside the water. Okay, the salt is still there, we just can't see it. What does dissolving really mean? Let's think about it. So we know that all matter is made out of particles. So make sure I'm standing in the right place. Okay, you can see on the left side, I've got a beaker or a cup full of these white particles. Let's say these are the liquid particles. Remember, these particles are close together, but they're not in rows and columns. They're just moving around all the time. Moving around, all jumbled up, but very close. Now, let's say we add a little grain of salt. Now, in one tiny little grain of salt, there are millions of particles, of solid particles. Okay, but let's just draw 6 because I can't really draw millions. So you can see up here, I filled them up. So they're black particles. Not that the salt particles are black, but just to see the difference between the liquid and the salt. Okay, so these are the salt particles, and these are the water particles. The salt particles, which is a solid, will be arranged in an order. Okay, in columns and rows. Okay, now as we add them in, as I said, we know that the water particles move all the time. If they move all the time, they'll break the forces between the salt particles. And the salt particles will be separated from each other by the water particles. So what it's going to look like is something like this. We're going to have one salt particle here, one salt particle there, one salt particle here. Okay, we'll draw another one there and probably one more because there's 6. So now we've got the salt particle, make sure you're going to see it, okay, over on this side. They're all jumbled up, separated by the water particles. And because there's not that many salt particles, we're not going to see them, okay? We're only going to see the salt if we have millions and millions of particles clunked together. But when they start separated, we can't see them. They're still there. How can we know they're there? We tasted that. Yummy salty water. Very good for your throat, okay? Coronavirus, you just go like this. Oh, and you swear it out. Anyway, completely nothing to do with what we're talking about, but it is good for you, actually, salty water. But anyway, that's what dissolving is, okay? So now, I'm going to give you continue in a minute and show you what I'd like you to do at home. Okay, so now for the activity that I'd like you to do. In any scientific investigation, we always find a link between two things. If we change one thing, how it's going to affect the other thing. And the question I would like us to think together is, how does the temperature of the water affect how much I can dissolve, how much salt I can dissolve? And to understand this point, I need to explain another term. I'm sure that that some of you, when you drink tea, you like to add a little sugar, right? So some of you might add 1 sugar. Some of you might not have any sugar at all. Okay, I don't drink sugar in my tea. Some of you add a teaspoon. Some of you, I imagine, even put 2 teaspoons. Any of you guys, you put 3 teaspoons. Some of you might even put 4 teaspoons. I hope not more than that. Not even 4. It's way too much. But some of you will put quite a lot of sugar. Now, what will happen at some point if we add 5, 6 teaspoons? What will happen eventually? At some point, by adding more and more sugar, it's not going to dissolve anymore, isn't it? The sugar will just fall to the bottom, and you can't. The more sugar you add, it's not going to dissolve in the water. We say that the solution is saturated. So a saturated solution is a solution that you added so much of that solid, whatever it is, sugar, salt, that it can't dissolve anymore. And what I want us to find is, what's the saturation point? How much solid we need to add for it not to dissolve. Okay? And more important, what we're trying to really find is that saturation point depends on the temperature of the water. Okay? When I increase the temperature of the water, will I be able to dissolve more or less? Or maybe it's not going to make a difference. What do you reckon? Okay? If I'm heating up the water, make it hotter and hotter, will I be able to dissolve more salt? Less salt? Or maybe it's not going to have any effect. Okay? So this is what we're going to try and do. I think if you've got one of these little teaspoon-like cake measuring spoon, this is a 1/4 spoon, I think that will work the best. So what I'd like you to do is work with 3 different temperature. So one could be cold water from the fridge. Or you can just add a few ice blocks, just make it really cold. Okay, so that will be our cold water. Then we're going to have normal water, just room temperature water. Pour it from the tap, add it in. Okay? And then we're going to have one hot water. So put the kettle on, heat up the water. Don't pour boiling water to a glass, because that's going to break. But you can pour hot water to a mug. So you can work with a mug. Maybe it's best to work with a mug. Don't break your mum's glasses. Okay? So you have very cold water, normal water, and hot water. Okay? Now, in each one of these cases, I want you to start adding 1/4 of a teaspoon at a time of salt or sugar. I think salt will work better. Salt dissolves better. So add a 1/4 teaspoon, put it in, stir it. Count 1. Add another 1/4 teaspoon, pour it in, see if it dissolves. If it dissolves, great. Count 2. Add another one, dissolve, 3. If you got to, let's say, 5/4 of a teaspoon, and you stir and stir and stir, it's not dissolving, that you didn't manage to dissolve 5, but you did manage to dissolve 4, then you manage to dissolve 4 1/4 teaspoons, and that's what you write in the table. Okay? So your table will be, on the left side, you'll have the temperature of the water, and temperature of the water you can just write cold, normal, hot. Okay? If you have a thermometer, measure it. Fantastic. But if you're not, it doesn't matter. And on the right side of the table, you're going to have number of 1/4 teaspoon salt that are dissolved. That's it. It's a bit of a long one, okay? And you count. You dissolve, okay? If you manage to dissolve 5, great. If you manage to dissolve 6, fantastic. Okay? Now, very important to know is that when you go from the cold water to the hot water, you got to use fresh water. You can't use the water with the salt in it, right? You can't use the water with the salt, otherwise you're adding more salt. There's already salt in it, so you need to start from the beginning. Okay? I'd love you guys to do that for me. Do the experiment, record the results, fill it in the table, and then write down a conclusion in one line. As I increase the temperature of the water, can I dissolve more or less? So that's the second thing you need to do. And the third thing, I want you to think and see if you can explain it scientifically. Why hotter water can dissolve more or less depending on what you saw. Why? Try and think. Try and think in terms of moving particles. Okay, guys, that's it for me. Have a lovely week. Okay, and obviously all your answers, please put in your homework folder. Have a lovely day, guys. Goodbye.